Hello, everyone. My name is Anthony McIntosh, and with me today I have Cameron Hyan. We are going to be discussing our senior design project focused on eye tracking. So first, we will talk about our stakeholders. For operational stakeholders, or those who are directly involved with operating the product, we have Dr. Bonia Sharif, our stakeholder and also product owner. We also have any technical interviewers who would decide to use our product, and eye tracking researchers who would use our project to help further the research. In the containing business, we also have eye tracking companies, specifically Smart Eye, Tobii, and GazePoint, which are the trackers we use for this project, who would be affected by this software. And we have software companies who would hold technical interviews who may or may not decide to use our software as well. In the wider environment, we have any potential employees/interviewees who would be asked to use our product during their technical interview, as well as the general programming population who can benefit from any information that comes out of eye tracking research. We'll now introduce our development team. I'm Anthony McIntosh. I'm the product manager and also a developer on the core application. We have Garrett Ulmer, who is also a core developer. We have Jacob Cummings, who is an Atom developer working on the Atom plugin. Cameron Hyan, who is the development manager and squad lead, as well as another Atom plugin developer. Sanat Bandari, who was our primary web app developer, and Ziyu Wang, who is our final core developer. For our faculty and sponsor team, we have Dr. Bonia Sharif, who is our product owner and our sponsor, Dr. Brady Garvin, our tribe lead, Bill Browning, who is our project manager, Mark Montz, our coach, and also Cole Peterson, who was a development aide and helped the team with development after working on a similar project. So now to discuss our problem and the opportunity we saw. So our problem was trying to combine eye tracking data, or data you get from using popular eye trackers, with source code to try to provide new insight into how developers can comprehend code. We want to translate the raw data that we get from these eye trackers to the source code that any coder or interviewee would be looking at to try to develop information relevant to the source code. The problem is that the raw data from eye trackers is expansive, and it would be much too tedious to do this manually, and providing a software to do this gives us the opportunity to, one, automate this process and come up with more interesting and relevant information for researchers and interviewers regarding what a programmer is looking at while they're performing a task in a technical interview or simply working on code themselves. So we saw an opportunity here to create some software product that will translate this raw data from the eye trackers into data that is relevant to our source code, such as line and column number, overall XY position on the IDE or the integrated development environment, as well as things like the token that they're looking at and the type of the token that they are looking at. So now that we have a decent understanding of our problem and what we strive to do, I'll now pass it to Cameron to talk about the specific solution that we made, as well as the highlights that we got out of working on senior design.
Thank you, Anthony. So now we'll talk about the solution that we built. So our solution is a three-part solution. There is the core application, which is an application that interacts directly with the APIs from the eye trackers. So it collects and gathers all of the data and then sends the data to the Atom plugin the Atom plugin parses the data in XY coordinates and turns it into relevant data that interacts with the source code. So it takes an XY position in monitor screen space and translates it to a line and column position in the editor, so we can see what line number and what column number they're looking at, as well as Atom can also look at some of the more interesting data within the source code, such as variable names and token types that allows an even more interesting output relevant to the source code. And then CoderGaze Web is a web application that will eventually give the users access to basic visualizations based on data they've collected with the other two aforementioned products, as well as the ability to query the generated data. And now I'll talk a little bit about the highlights of this project. So this project builds a solution that utilizes cutting-edge eye tracking technology. We have a suite of trackers that we support, as well as it uses modern software engineering techniques to create software that can be scaled up and extended to work with other products in the future. And with this, I will also show a short demo of our product. So I already have these open in the background, but here is the CoderGaze core application as it currently exists. So I'm going to set the tracker to track the mouse for this demo. And then I'm going to click Start Tracking. And then I'm going to open up Atom, which is also running the Atom plugin. I'm going to connect to Core. And now I'm going to start tracking. And then toggle the highlighting. So we can see at the current mouse position, this is what the XY coordinates are being translated into line and column numbers that allow us to highlight the word that they're currently looking at. As you can see, if you follow my mouse, it is also highlighting. So now I'm going to toggle the highlighting off and then disconnect, stop tracking, and then I will open up a XML data file, which we have here. This includes a lot of the information I just mentioned. And now I will go back to the presentation and continue on into the values and lessons learned. We learned a lot of lessons doing this project. We learned the importance of requirement solicitation and deep project planning. Throughout the project, we faced many different challenges that may have been mitigated or even not reduced to being irrelevant had we planned out the project as we started learning how towards the end of the project. Also, we had to accept the possibility of items falling out of scope or being unrealistic given the time span. This is especially relevant with the COVID-19 outbreak, as many of our project goals were left on the cutting room floor simply because of a lack of access to the trackers towards the end of the semester, making it impossible to add new changes. Also, we learned how to work with multiple developers to create pieces of software that work together cohesively. And we also learned how beneficial it is to have a sponsor who is very involved and understands what they want and is very engaged and passionate about creating a product that they themselves want to use. And that was probably one of the biggest benefits of the project, was having a sponsor that could give us feedback actively and tell us exactly what she likes and what she doesn't like. And so we would like to extend a thank you for being such an involved sponsor to Dr. Bonita Sharif. And with that, I would like to conclude the presentation with a thank you to all of the people who helped make this project happen, including Brady Garvin, Bill Browning, Mark Montz, and all of the CoderGaze team. So thank you for watching our presentation,